We now look at this last example in your notes. Example 39 says that there is a z that satisfies this condition, modulus z plus 3 minus 2i less than or equals to 2. Now you want to first illustrate the locus of the point representing this complex number z on an Argand diagram. Alright, now we have seen this before. This is the locus of points inside and on a circle. Alright, I can first of all look at this. I can look at z minus 3 plus 2i equals to 2. I can first look at this, and this is the locus of a circle. The center is at minus 3, 2, and it has a radius of 2 units. Okay, now in your notes the diagram has been drawn very nicely for you. You have the circle here, alright, and the less than or equals to 2 sign just indicates that you have points inside the circle as part of your locus, inside as well as on your circle. So that's why your diagram looks like this. Now you want to first of all find the exact least and greatest value of modulus of z. So if points on the circle as well as inside the circle represents z, then the question you want to ask yourself is, where is the furthest point away from the origin as well as the nearest point from the origin? You want to find that length. So what you need to do is to look at your diagram and find out where these points are. Alright? Now if you look at your diagram, the point that is the closest to your origin is this point here. Now the point that is furthest away from the origin is this point here. Can you see that? So all you need to do is to calculate what is this length for the shortest distance and what is this length for the longest distance. Now let's mark down the shortest and the furthest distance away from the origin. If you look at your diagram, the shortest distance is indicated by OD and the furthest distance is OE. Okay? Now, how to find OD? Now if you look at the point OD, or rather the length OD, OD actually is part of a right angle triangle here. Okay, right angle at B, and the length of the base here is 3. The height of this triangle is 2. Alright, now Pythagoras theorem will tell you the length of the hypothesis, and this is just square root 2 square plus 3 square, giving you square root 13. Now once you have all this, then straight away I can write down OD, because OD is the same as CO or OC minus CD. And what is your CO? CO is your length of hypotenuse, square root 13. Then what is your CD? CD is your radius of circle, so square root 13 minus 2. OE can be found straight away once you have found OD, because OE is the same as ED plus DO. And if you look at ED, ED is just the diameter of the circle, so it's 2 times 2. And what's DO? DO is OD, and that's just square root 13 minus 2. And then now you have your answer. Square root 13 plus 2. Done. Now let's fill in this information into your notes below. Okay, now you have length of OC, which is actually square root 2 square plus 3 square, and that's square root 13. Your least value of Z is the same as OD, which is the same as CO minus CD, and then that's square root 13 minus 2. Then greatest value of mod Z is the same as OE, which is the same as ED plus OD. So you have square root 13 plus 2. Okay? Now in part 2, I want to find the range of argument z, meaning I want to find out what kind of values can argument z take. Now argument z means I'm looking for the angle that the point representing this z to O makes with the real positive axis. So if you think about this and you think about the possible values of z are points rather on the circle as well as points inside the circle, then you can easily see that the least angle that I can find will be the angle that AO makes with the real positive axis. Any other point inside the circle or on the circle will have an argument greater than this. Now what about the largest possible value? Now the largest possible value of the argument of z must be from the point B, because OB will make an angle of pi with the real positive axis. So straight away I can write this down. Argument z must always be bounded by pi. Now on the other side, I need to find this angle. Now how do you find this angle? Now let's just consider this triangle CAO. Now this is a right angled triangle, okay, and in particular is the same as this triangle. They are all right angled. CBO and CAO are the same. So let's put down what we know about these two triangles. Okay, and this is 3. And if I call this angle theta, then this is also theta. Okay? So if I were to write down the least possible argument, then this would just be pi minus 2 theta. So if I know what theta is, I will be able to find the range of argument z. So what is theta? Now look at any of the two triangles. If you take tangent theta, you will always have opposite over adjacent. And this will give you tangent inverse 2 over 3. Alright? And then you can press your GC, okay, to give you this number. In particular, I'm interested to find out what is pi minus theta. And pi minus theta turns out to be 1.97. So that means this number here is 1.97. Done. So again, let's fill in your notes with the information above. Now, tangent theta is equals to 2 over 3. This means your theta is tangent inverse 2 over 3. So the least possible argument of argument z is pi minus 2 theta, giving you 1.97. Okay? And because the largest possible value of argument z, okay, let's put that in, largest possible value of argument z is pi, I can straight away say this. The range of argument z is from 1.97 to pi. Done. Now for the last part, what we want to do is to find the least value of modulus z minus 3 minus 2i. Now remember, the meaning of modulus is distance. So if you look at this and rewrite this as z minus 3 plus 2i, then this is actually the distance between a point representing Z and the point 3, 2. And if I were to plot 3, 2 on the Argand diagram, 3, 2 appears here. And very quickly, you can see that it's actually on par with the point C, because C has the coordinates minus 3, 2. Okay? So if I want to find the least distance between any point inside the circle and on the circle with the point F, then I can very quickly see that this distance is this one here. That's the shortest distance. And that shortest distance is actually something that I can write down very quickly. Why? Because that shortest distance is this distance minus the radius of the circle. And what is this distance below? It is 3 plus 3. And what is the radius of the circle? 2. So the least value of this modulus is the same as 3 plus 3 minus 2 equals to 4 units. Let's put all this into your notes below here. Now the least value of modulus Z minus 3 minus 2i is the same as the least value of mod Z minus 3 plus 2i. Alright? And this is actually the shortest distance from 3, 2 to the locus. And this shortest distance is FC minus the radius of the circle, which is 2, and then you have 3 plus 3 minus 2 equals to 4. Done.